Hey everyone, welcome back to Daily Coding. Today is day 43. I'm looking at dynamic programming problems. So yesterday I did longest increasing subsequence. I got a pretty cool solution for that despite some struggles. And then today I'm looking at partition equals subset sum. So I've never looked at this problem before. And same as yesterday, my emphasis is going to be on the dynamic programming problem solving approach instead of necessarily trying to solve the problem. So it's more important that I just kind of look at it in the methodical dynamic programming way rather than actually solving the problem itself, because that's what I really want to improve on is just the thinking and everything, right? So, okay. So like always, it looks pretty simple, but it looks easy to understand what's happening, but maybe it'll be complex to find the solution. Okay, so let's see. Partition equals subset sum. You are given an array of positive integers and nums. Return true if you can partition the array into two subsets where they have the same sum. Okay, otherwise return false. Okay, so we need to create two subsets that have the same sum. So here, for instance, and I guess so because it's a partition, that means every element must be included within one of the subsets. So like, you can't just say 1 and 2 as one subset and 3 as the other because you need 4 in there somewhere. So we're partitioning it into two subsets. The first subset is 1, 4, and the second is 2, 3. Okay. All right, so sorry, I have something in my keyboard. All right, so did I just exit it? Oh man. Okay, so what I was thinking is if we want to draw out a decision tree for this, so we know we're always going to have two subsets. So we can think about it like if we look at the decision tree. So we have two subsets. So let's say we have 1, 2, 3, 4. So the way I'm thinking it is, okay, so we look at this first number. We have two choices. We can either add it to the left subset or to the right subset. Right? So if we add it to the left subset, then we'll have 1 for the left, empty right, and then 2, 3, 4 remaining. So I'll just say 1 and empty. If we add it to the right subset, then we'll have empty for the left and 1 for the right. Okay. Then I is now 1. We're looking at 2. So we can add it to the left subset. 1, 2. Or we can add it to the right subset. 1, 2. Same thing. So here we can add it to the left subset. We get 2, 1. Or we can add it to the right subset and we get empty list and then 1, 2. Okay, now from each of these, I'm just going to underline these to more rigidly define each subproblem here. Okay, so then here we can add 3 to either one. So we can either have 1, 2, 3 empty, or we can have 1, 2, 3. And here we can have 1, 3, 2, or we can have 1, 2, 3. And then same thing, we can have either, so it's getting a little tight. So we can have 3, 2, 1, or we can have 2, and then 1, 3. And then here there's 2 more. So we would have 3 here with 1, 2, or we could have empty 1, 2, 3, and so forth, right? And then, so we'll do each one of these will have 2, right? And then what we do is check if any of these have the same sum, right? So we would check for each leaf node, does the first subset sum equal the second subset sum? And then we return true if any one of them are true. Okay, so obviously there's some repeated work going on. So for instance, we know that this is going to have the same answer as this. So these will have the same answer, and these will have the same answer. And I guess that also means that these will have the same answer. So we really, like, what I'm trying to say is the problem's symmetrical. So for instance, if we partition like the left and the right to be like this, that's the same as this. So that being said, we can cut our problem size in half by basically never computing. We don't have to compute any of this, and then we don't have to compute any of this. No, we do have to compute this because these two are not symmetrical. So we do have to compute. So I think basically what we do is just don't compute this whole entire half. So it would be 2n divided by 2. So 2n minus 1, is that the... Does it only reduce it that much? I guess we double it one less time. Yeah. Okay. So yeah. So this would just be 2 and then n minus 1. So it's still pretty big. For instance, if we had just one more level, then we would get this, you know, all of that. We'd get this with one more level would equal the same count as all of that because we're doubling it every time. Okay. So that's some repeated work that we can avoid is we don't actually have to do this part, like any of these. All of these should be unique from here on out though, because these are completely different. These are completely different. These are completely different. So yeah, we don't have to do any of that. Even still, I think that's not fast enough. Okay, so that's the, let me make a new layer. Okay, so this is the decision tree. So now I'm thinking, let's think about the subproblems. So basically we want to know so what would the subproblem be? It's if any of them are true. I'm trying to think of what the base case would be. It's like if one sum equals the other. But it's a little tricky because, so if you just have 4, it's not really true. So I don't know what the base case would really even be. Because with a lot of these problems, it's like you start from here and you know that this one's true or it's length of 1 or whatever. So this one, does it have to be, so the length could be 1. So if the length is 1, my understanding of the problem would be that, so maybe we start with false actually. So we know that if we have one value, it has to be false, right? Okay, I just had another idea too. Okay, so this, because if you have only 1, then you partition it into 2 subsets, then like let's say your input array was just 4, the only way that you can, there's 2 ways. So one would be this, and the other would be the, you know, symmetrical version of that. That's the only way you can partition it. I do not believe that you could do this. I think this is not possible because you are introducing 2 elements. So, okay, so we know if you have 1 element, it's always false. So maybe we can keep track of the balance. And what I mean by that is, so we know if we have just 4, right? And I'm not going to draw any symmetrical entries. I'm just going to draw one side of the symmetry. So anytime I draw this, we can assume that there also exists the symmetrical version, but instead of drawing it every time, I'm not going to do that. So now this information tells us if we had a 4, then we could make it symmetrical. And we have to know, yeah, okay. So this kind of tells me like this guy's saying like, I need a 4. Okay, so let's say it's not a 4, let's say it's a 3. So now there's two possibilities. We can need a 1 or we can need a 7. And I still think that this is going to be 2n, but it is interesting to think about. So we can need a 1 or we can need a 7. Then we get 2. So now we could need a 9. So now I think there will be 4 outcomes because it's, well, I guess it would just be like, so you have 4, 3 together. So I'm just going to draw it like this. So you could have 4, 3 with nothing, or you could have 4 and 1 and 3 in the other. So you need 7 here, or you need 1 here. Okay, so now if we add a 2, well, I suppose there's only 2 ways you could even, no, there's 3. Wait, you could add a 2 here. So if you add a 2 here, then that means you would need 9 to go here. If you add a 2 here, then that means you would need, this would be 2 and this would be 7, so you would need a 5. If you add a 2 here, it would be 6 and 3, so you would need a 3. And then if you, add a 2 here, you would need a 1. So what we could do is just have a set and just keep adding to the set, like all the numbers that we could need. So we would basically just have a set, but in order to calculate these numbers, you would have to do, you'd have to basically do what I just did, which would be, I'm not sure if you can derive it from 1 and 7. You would need the 3 and 4 because you need to know how that gets split up. Okay, and then for lastly, we have a 1, so we see that 1 is in here, so that tells us, yes, we can balance it. Okay, so if I could somehow derive these numbers from the 1 and the 7, then that would be totally fine, but I don't think that's possible. Oh wait, is it possible? Because I'm noticing, it could be coincidence, but I'm noticing we have 5 and 9 and 2. So if we look at 7, 7 plus 2 is 9, and 7 minus 2 is 5. I don't know if that's a coincidence. It probably is. Let me try with a different group of numbers that aren't in weird ascending order, because they don't have to be in ascending order, right? No, okay. So let's try 6, 5, 4, 7, like this. So in this case, you could partition it. 4, 7 can make 11, and 6, 5 can make 11. And just, yeah, that's fine. Okay, so 7. At this point, we need a 7. That's the only thing. And then when we add 4, so we can either have this, yeah, so that's the only thing we have. When we add a 4, we either need an 11 or 3. Okay, so here I added 4 and subtracted 4. Okay, and then 5, let me do it out by hand first and then see if I notice a numerical relationship. So we can either have 4, 7 or 4, 7. we do that. So we can either have 4, 7 in one group and nothing in the other group, or we can have 4 in one group and 7 in the other group. Okay, so 5. If we add a 5 here, then we would need 2. Okay. I'm thinking maybe you take the absolute value of that, perhaps. If we add a 5 here, this would become 12, and we would need an 8. If you add a 5 here, so wait. That I don't like the way that I drew this. I'm getting confused. I think that's right, but for down here. So here you have 11. So if you add a 5, okay. So what I just said is correct over down here. So if you add a 5 here, it would be 9 and 7. So you would need a 2 to equalize it. That's this 2. If you add a 5 here, this would be 12, and then you would need an 8 to equalize it. Now we'll consider these. So if you add a 5 within this group, then it would be 9 plus 7, 16. So you need 16. Or if you add a 5 to this group, then it would be 5. So what's the difference between 5 and 11? 6. Okay, so I'm noticing something. I don't know if you guys are also noticing something. So these numbers are basically these numbers plus or minus 5. So it is growing every time though, so I don't know if that really saves us any time. So we can define it as, so we take 7 and then we plus or minus 4, and that gives us 3 and 11, and then we plus or minus 5, and then we get 8 and so let's say that this is the minus, so minus 5, and then we take the absolute value of that, so 2 or 8, and then here we can, plus or minus 5, so we get minus 5, 6, plus 5, 16, and then we can just check, does 6, and then when we get to the last number, we say, does 6 exist here? Okay, so that's another way of thinking about the problem. In terms of calculations, so here you have to do, so here you do like 0 calculations, maybe 1. Here you do 2, here you do 4, then you do 8. So n levels, it's 2 power n, and a level is this. So it's still 2 to the n. It's still 2 to the n. Okay. So yeah, you do 1. Well, I guess you would do 4. It would be like 2 times to the n. You start with this, and then you do 2 calculations, then you do 4 calculations, and then that's it. So I think it's maybe that or this. I think it's this, because 2, so if we just have 7, it's 0 calculations. Well, okay. So this is still useful to know. Is there any shortcuts or anything that I can deduce. Like maybe if we have 16, we can get rid of something else or something like that. Or maybe I could try coding this, see what happens. But it's not always sorted either, as you could see. Okay. So what is I think maybe I'm focusing too much on this problem itself. So let's look at the dynamic programming like patterns. So let's say we know that this is true. Then if we add another element, it has to be false. That's true. That statement is true. So like if we have anything that's balanced and we add another element, it has to be false because there's nowhere, unless it's 0, no, it's positive. Okay. So that might be important. So for instance, we know that this is solvable. So we know that if we add one element, it will not be solvable. So we're kind of going in and out between balance. But we can't say that the other thing, like the opposite of that, is false. So if we have something that is balanced, right, like 4, 4, 8, for instance, and we know that this is actually, let's say we have something that is not balanced, for instance, 4 and 5. This is false. Adding any other number doesn't guarantee it to be true either. So like just because we add something else doesn't make it true. Only a couple certain numbers will make it true. In this case, 1 or 9. And then this grows every time. So my only problem is like, so is there a way to shrink this or reduce it in some way? Is there a pattern between the numbers? So we see 4 plus 7 and 7 minus 4 and 7 plus 4. So maybe we can define these as 7 plus 4 and 7 minus 4 plus 5 and minus 5. Plus 5. So yeah, there's still 4. So you can change the sign every time. Maybe that's it? Okay, this is kind of a little more interesting. So I still think it's to the end though. So even if we have, so we can represent it as, okay. So we have 7 plus, so let's just look at the first two numbers, right? So it's either 7 plus 4 or 7 minus 4. Then when we add 5, it's 7 plus 4 plus 5 and 7 plus 4 minus 5. And then here it's 7 minus 4 plus 5, and here it's 7 minus 4 minus 5. So we can essentially encode this to, if 0 is plus and 1 is minus, 0, 0, 0, 1, 1, 0, 1, 1. But this is still 2 to the number of digits. So is there a way we can do it without checking all the combinations? So I'm just essentially representing the same thing in several different ways, but it's too slow because it's 2 to the n. Well, maybe we can simplify 7 plus 4 and 7 minus 4. So we can say it's 7 plus 4 and 7 minus 4. So now this is either it's either 11 or 3. This is pretty much exactly what I was doing. And then, yeah, it's the same exact thing. So I'm struggling to find the repetition or some way that we can. Basically, I don't know the dynamic programming element. I'm struggling to find ways that we can store something or save time, because everything I thought of so far is still 2 to the n, like the possibilities double every time. The only way I thought of doing anything was when you cut the problem size in half, but that doesn't really matter either. So there must be something we can store. The other thing I thought of is if it is true and you add anything, that would disrupt it. But it doesn't go the other way. So when we start with an empty list, that is true. This can be partitioned. Then we know that because we added something to a true one, it'll make it false, whatever it is. And that's why a single element is false. 2 elements is only true if they're the same element. So we can assume that 2 elements is also false, unless they're the same. 3 elements, the sum of one must be equal to the other. But you have to check all the combinations for that. I just really don't see how I can save time or memorize something. What can I memorize? I don't think it's just that. Let's go back to the decision tree. So it's like we need to consider both of these. And they don't have to be unique, right? No, it doesn't say that. They have to be unique. Because I was thinking, like, if they had to be unique, we know that this one we can cancel. Well, yeah, we could cancel that out because we need a 1 or 2 to solve it. Well, not necessarily, because you could add like a 4 here and a 5 there, and that would work. What about could it have something to do with the absolute value, and when it flips, can that tell us some information? Because here 3 minus 5 is -2. So what that looks like is if we have one subset is 7 and 1 is 4, right now we need a 3, but if we add a 5 here, then we did 3, which is what we needed, minus 5. So now we need 2. But it flipped to this one. So we say, like, we need a -2, but since it's flipped over here, then we take the absolute value. Could we do something with negative numbers? Like if we need it in the left or if we need it in the right, can we do that? So maybe instead, could we look at it as this sum minus this sum? Or something like that. And then I don't really know why that would help. So we could either, so here we would have either 7 or -7. because, so it would either be this or this. And then 4, so now I just doubled the problem size basically. So maybe I was saving half the space and I just didn't realize. I think this way reflects that you save half the space. And then can we make some, just something here? So if we get 4, then we would want negative 3. Maybe instead, could we just take the current sum, perhaps? So we can represent this instead of 1, 2, we can represent it as 3 empty list. And then here we can represent this as 3 times 4, 6 empty list here. And here we can represent it as 3, 3. So should we just store the sum as we go? What would that do for us? It doesn't really change anything. I can only think of one shortcut, and if that's like, if this is true right before we're done with the answer, then we know that it's going to be false. So we don't have to calculate the last one. But you can go from false to true. Okay. So I'm a little stumped. So for now, I'm just going to code this because I'm kind of stuck. I don't know exactly where to go from here. Yeah, I don't know where to go from here. 1, 4, 2, 3. So what path would get us to 1, 4, 2, 3? It'd be this one. This path. Is there a way we could have known? It's not sorted. Could we sort it? Could we sort it? Maybe that's actually a good trick. That might really help us, actually. That might really help us. That might really help us if we sort it. Okay. All right. Let's assume that we only work with sorted arrays. Okay, that's only n log n, so that's completely fine for this problem. I cannot draw though. Okay, so let's assume that we just sort our input right away. And now we work with sorted. So let's think of a sorted example that would work. Well, 1, 2, 3, 4 would. What about 2, 4, 6, 8? Does that work? 10 and 10. Yeah. Well, okay, so with sorted, okay. So with sorted, we know that you can never divide a sorted like this evenly. Is that true? Well, we know this value has to be greater than this value by, let's say, some amount x. The sum of these can be greater than this. So if we have, let's say, 7, 8, 9, the sum of these is greater than this. All right, let me try what I was doing before, but with sorted and just see. I think this is definitely on the right track though. So if we have 7, 8, 9, and then, so, okay, so my question is like, is it always going to look like we don't evenly partition it? I don't know if this is even relevant, but like, is there ever a case where we can partition it like that and that it's sorted? No way, right? Well, actually, yes, definitely yes, actually. So if we have 7, 8, 9, the sum is 15. Wait, maybe not. Because I was thinking we could put 4 here, but we cannot. This number, yeah, I think I was on the right track before. So like, this number has to be bigger than this one. Which means using that, if we think about it like this number has to be bigger than that one. Okay, so let's do like, even though they're close, this one has to be bigger. So then if you need, so like this amount is how much you would have to decrement it by. So yeah, it's not possible. So are we always going to have this sort of pattern where it's 1, 2, 3, 4, and then it looks like, you know, you group it like this? I don't know. Let me just write some sorted examples here. Let's say 12. That's. I want to try to get a group that isn't just like this and then that, but does it have to be like that? Let's say we have 1, 3. So I want to group. Can we do it like that? No. So maybe can we use the fact that I can't think of any examples to our advantage? Let's go back to 1, 2, 3, 4. Okay. I think the sorted is definitely, I'm kind of drawing blank right now, but I think the sorted gives us a lot of information. So we know that this number, okay, so let's start here. So the sum is 1. So that means, what can we deduce from that? That there has to be at least 1 on this side for it to be true. I don't think that's really that useful though. Okay. Then here the sum would be 3. But we can also skip it and say that the sum is 4, or we can say that the sum is 5. It has to do something with the sorted. Or does it? Or am I just, is it a red herring? So this should work though, right? 1, 2, 3, 4, 5, 6. Does this work? So my guess would be like 7, 9. It doesn't look like it works because what if we had 9, 11, then 10? It doesn't really look like it works. If we had another 5 here, this is 10 and this is 10. Okay, this is an interesting example. So did I disprove my own theory before? Because this, we're partitioning it like this. Or if we just have like all 2s. That's also possible. There's some inference that we could make. I feel like there's some inference we could make. Okay, so let's say 1. So we know that this has to be... There has to be... Oh, wait. So we know that this part has to be off balance by 1. Right? And then this part, so then if we look at here, that means this part has to be off balance by... So now this is where it's like annoying because it seems like it's doubling again. It has to be off balance by 1 or 3. So maybe we can figure out the... And then here, it's the same doubling effect though. I was thinking maybe we could use that somehow, but it keeps doubling again. But can we use the sorted feature? So here, so this has to be off balance by 3 or 1. This has to be off balance. Let's try the other way. So the empty list is off balance by 0. This is off balance by 5. This is off balance by either 0 or 5. I think that's just a coincidence that it's the same two numbers. This is either off balance. So this is either off balance, and then we look at this, and then it tells us by 4 or 5 only, or 9. Well, or it could be 4 plus 5 plus 5. So this could also be off balance by 10. So we could also be off by 14. Now this tells us, well, we want to be off balance. So this has to be off balance by 1. This could be off balance by 3. It just doubles. It keeps doubling. I don't know. I'm not using the fact that it's sorted at all. I feel like that could help us because we know that the right half, okay, if we make an assumption, we know that the right number has to be greater than or equal to the left number. But I don't know if that even matters because we could put it into either one. So I don't know if that even matters. Let me try a new example. Maybe, all right, let's say 1, 4, 8, 16, 20. Too many multiples of 4. Let's say 13 and 18. Okay. So here it's off by 0. So here it's off by 18. Here it's off by either 5 or 3 plus 18. Sorry, 13 plus 18, 31. It's just doubling. It keeps doubling. So, okay, so the fact that it's sorted may not actually matter at all. Because we're still going to add and subtract it. So, like, even though it's greater than 13, we can't really use that information to help us. What can we... What... For for sure we know that this has to be off by 18. I like this way of thinking. This seems more right to me, but I don't know what to do with it. Because when we get here, so can we just know if it's off by 18? If it is off by 18, we return true, otherwise false. So now we calculate, is it off by 18? How do we know? All right, and then this, how do we know if it's off by 18? We want to know, is this off by 13? So we can make it off by 14, by 13, which means that this will be off by 0, so we have to check all the ways to see if we can make it off by 18. Yeah, guys, I don't know. This might be one that I would benefit from looking at the solution because I'm getting a little stuck. And then I guess I could try coding the brute force solution just for practice with that. And then I'll probably have to just look at the solution. So I'll try this approach with the numbers. Okay, so how do I want to organize this data? So, okay, so officially now I'm going to code this solution. I'm going to code this solution. So we're going to have a set called, that's not how you do it. We'll just say visited, I guess, which is a set that contains, could we do it the other way as well? So could we say, so 6547. So if we have 6, 4, 5, 7, like this, 6, 4, 5, 7, then could we say, so 6, the next one has to be off by 6. Then 4, the next one has to be off by either 2 or 10. And then 5, the next one has to be off by either 3, 2 minus 5, 7, 5, or 15. And then here we see 7 is a part of this. So we'll go from, okay, so for I in range, 0 to length of nums minus 1. And then I suppose what we could do is say, you know, maybe a more mathematical way of doing it would be then you do 7 by all of these. So you'd say 4, 10, 0, and then you encounter the 0, and then you say, okay, we found a 0, so there's a possible solution. Okay, so we're going to do this. And I guess we can have it be a queue. Like that. All right. And within it, we will have nums of 0. So that would be 6. All right. And then we're going to say for I in range, while q, we're going to basically want to do it. So we'll say L equals length of Q. Then we want to pop L So basically what I'm thinking is, so we get the length of Q, and then that many times we add two things to the Q. So we'll say Q dot append left would be, so nums of I plus current. So for nums of I plus current, so current is in this case 6. So then for everything, so L equals 1, while L is greater than 0, current is 6, and then we want to say add this number to it and subtract from it. So say nums of I plus current, and then we'll say the absolute value of nums of I minus current, and L minus equals 1. And then after we exit this loop, we'll just say I guess we could just do it the mathematical way. So current, and then if any of these, so we'll say added equals this. Then we'll say subtracted absolute value of this. If added equals 0 or subtracted equals 0, we'll return true. Otherwise, we'll just add them. Then if we get to the end, we will return false like this. Okay, let's see if, I'm guessing this will, okay, let me just print out some stuff here. Print current and nums of I. Actually, let me print Q also. Q is 1, 1. So it's saying 6 minus 6. So how do I avoid that from happening? So I want it to start, I guess start with 4 then. So in range 1. I'm doing something wrong. Current is 3? Okay, 1, 2, 3, 4. So let me just debug this code. So our Q starts with 1. And then we'll say L equals 1. While L is greater than 0, current equals 1 added. So added equals nums of I, and I is 1. So 2 plus 1, 3. That seems right. So if we add them together, that means we need a 3. If we subtract, then we get nums of I nums of I 2 minus 1, which is 1. So maybe it should be 1 minus 2. Is that the problem? I honestly forget how I did it. Okay, so that looks good. And then we append them to the queue, append left. So the queue is empty. So then we append, I don't think it matters which way we do it, 3 and 1. Now this exits. Now we go to I equals 2. So L equals 2 now. And current equals q.pub1. Okay, so we're going to do this twice now. So current equals 1. Added equals 3 plus 1. Which is 4, and subtracted equals nums of I 3 minus 1 is 2. Alright, let me print so subtracted is 0. So nums of I equals current. Why? So we added, which is 3. And then we add subtracted, which is 1. Does the order matter? I don't think the order should matter. No. So let's see what nums of I is and what current is. Nums of I equals 3 and current equals 3. Why does current equals 3? Oh, well, it is balanced. Oh, yeah, I guess this is working as intended because it is balanced at this point. But we only want to check for the last one. I guess it was kind of working as intended. Let me print Q. I mean, we could just return if 0 in Q like this. No, it doesn't work. What? How is 0 in there? Okay, maybe that's what I wanted. Yeah, this still isn't. I mean, it's not good enough. Let me see if it gets accepted on LeetCode. It'll definitely TLE. Because it's still 2 to the n. What's it called again? Partition equal subset sum. Partition equals subset sum. Should TLE output. Yeah, like this, I have zero faith that my solution will do that. Print. Also, this part is n as well, but I guess it doesn't really matter. Am I printing anywhere else? Memory limit. Okay. Yeah, so I'll definitely make sure to look at the solution for this one. It stumped me a lot, but I think I had good thought processes for most of it. Yeah, so this, it's been about an hour. Maybe I spent a little too long on this problem without looking at a solution, to be honest. But yeah, so I'll leave it at that. Thank you guys for watching. Today was day 43. And I'll see you guys tomorrow for day 44.